In this video, we're going to continue section 7.2. We are looking at describing data, and right now we're going to focus in on measures of variability, which is looking at how spread out the data is. Okay, so when we're talking about looking at how spread out data is, like for example, we had been using commute times in our examples in the previous videos. Let me go ahead and write that down. So for our commute times, we had 6, 10, 11, 11, 17, 18, 20, 29, and 48. Okay. So those were commute times in minutes for students going to OCCC. Actually, by the way, just so you know, these were actually taken from a class. So I did actually get this information from students. All right, so if I want to know how spread out the data is, we kind of see the data here. And in our video, we talked about the box plot. You can kind of see how spread it out is there. Most people would probably kind of look at the lowest value and the highest value. And that is what we call the range. So the range is literally the highest data value or minus the lowest data value, which I'm just going to write highest minus the lowest because I'm feeling a little lazy. That's fine. So looking at mine up here, the range would be 48 minus 6, which is 42. Big range between commute times, a 42-minute difference. All right. So that kind of just is giving us really not much. Okay, so there you go. That's the range. And after that, it's not much else. So we need more. We want to look more into depth at how we can determine how spread out data is. And then we kind of, instead of looking at it from highest to lowest, we start to look at it from a central tendency, from one of the centers. So when you look at maybe how far it is from, in the case of the median, which is something we found for this, or the case of the mean, which is something we've also found for this, that can be something that might be useful. So that's what we want to do. Before we do that, though, I want to give another example of why just knowing the range may not be enough, and kind of see what we might want to kind of dive into here. So let's consider two sets of data, and we're not going to even give them any sort of label. All right, we're just going to give some values. So set A, I'm going to call it A, capital A, is the numbers 1, 2, 3, 3, 3, 3, 3, 1, 2, 3, 4, 5. There's 6 threes, okay, and then a 4 and a 5. All right, there we go. That's set A. And let's see, I think there's supposed to be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay, cool. All right, and then set B is 1, 1, 1, 1, 4 ones, then a 2, then a 4, and then 5, 5, 5, 5. 4 fives. Okay, there we go. Two different sets here. And you can see that if I wanted to find the range for each set, they're the same. The range is going to literally be 5 minus 1, which is 4. Okay, boring. I do notice, though, that these sets do look differently. Yes, their highest value is 5, their lowest value is 1, but there's a lot of stuff going on differently here, okay? I kind of already alluded to the fact that we're going to want to look at a central tendency. So let's find the mean for each of these, okay? The mean for set A. So go ahead, grab your calculator, add those values together. I already kind of told you there's 10 of them. When I add them together, I get 30 divided by 10, which is 3. And for the set B, and I add them together, I get 30 divided by 10, which is 3. So I get the same mean. Okay, but still, these do not look the same. There are a hell of a lot more 3s in set A, where set B has more 1s and 5s. So there's like more distinction in set B between the values that are there. I have two modes in B and only one mode in A. So it kind of, I want to express this difference. All right. And right now, the range isn't showing me that. The mean isn't even showing me that. If I try to find the median, by the way, it's going to be 3. The only thing that's going to be different is the mode. The mode is going to give me a little bit of difference, but we'd like to find something more meaningful. And here's what it's going to be. We're interested in finding the average distance. The average distance, a data value is from the mean. That's what we're after here. I'll even call it my goal. Now, there's 2 ways to do that. One way is kind of really only taught at the elementary level, like the secondary level, sorry. And the second way is the way that's actually used within statistics, okay? So the first way is what's called the mean deviation. Now, this is kind of literally taking what we just said and finding the average distance a data value is from the mean. Okay, so here's how we do that. We would find the mean. Okay, then we would find the difference between each data value and the mean. Sorry, let me shift up here. I'm kind of running out of space. Each data value and the mean. Now, when you subtract every data value and you subtract the mean, you'll end up getting some negatives and some positives. And that's where we kind of have a problem, okay? So in order to deal with that problem, we're not going to just add up negatives and positives, which are going to end up canceling out, okay? Because some values are bigger than the mean and some values are smaller than the mean, okay? So we get positives and negatives. That's what I mean. So instead, we make the differences positive. Wow, that's supposed to be okay. Make the differences positive. So every difference that we found, a value that's smaller than the mean, instead of writing a negative, we're going to go ahead and write a positive. What we're really finding is what is literally called the distance. And on a number line, by the way, when you're talking about distance a data value is from some value, so like from 0, okay, 2 happens to be the same distance from 0 as -2. All right, they both have a distance of 2. Wow, of 2. Sorry. Wow, I wrote 3 anyways. That's so weird. What's wrong with my brain? It's broken. Okay. They both have a distance of 2 on the number line. And the way we can represent that is an idea called the absolute value. The absolute value takes and says, how far is -2 away from 0? Well, the answer is 2. How far is 2 away from 0? Well, the answer is 2. That's what the absolute value is finding, the distance. So we're taking all of these differences and thinking of them as how far they are away from the mean, and therefore we want the positives. All right, that was a lot of explanation and a weird brain tumor. Okay, so now once you find all these positive values, you get all these positive values, you'll find the mean. Find the mean of the distances. So I'm literally doing what I wrote above. I'm going to find the average distance a data value is from the mean. So I'm going to find all how far away they are from the mean. I'm thinking of them as positive numbers, and I'm going to literally average them. Okay, great. Let's do that. Let's do that for set A. Okay. And we'll do it also for set B, but let's start with set A. Okay, so for set A, here's what we're going to do. I'm going to kind of create a little table here to help me. So the first thing I'm going to do is list all of the data values. Okay. I'm going to need more space than that. Sorry. All of the data values. And then I'm going to subtract, and here we're going to call all of these data values x sub I. That's referring to their order, right? X sub 1, x sub 2, x sub 3. So in math, in general, we say x sub I. So I'm going to take x sub I and I'm going to minus the mean. Or in other words, I'm finding the difference. So this is the data. This is the difference. And then once I'm done with that, I'm going to find the actual distance, which is the absolute value of each of these. So I'm finding the distance. Okay, cool. Let me write all the data values down. 1, 2, and then there were 6 threes. 1, 2, 3, 4, 5, 6. And then it went 4, 5. Okay, and I happen to know, I already found that the mean is 3. So basically, from each of these data values, I'm going to minus 3. I'm going to write it down for the first couple. So I'm going to do 1 minus 3, which is negative 2. 2 minus 3, which is negative 1. 3 minus 3 is 0. And then basically, I'm going to get 0, 0. Here, sorry, I got to draw the halfway mark so I can kind of tell how many zeros I need to put in where. Okay, shift this 0 up a little bit here. 0, 0, 0, 0, 0. 4 minus 3 is going to be 1. 5 minus 3 is going to be 2. And there we go. Okay. So now I'm going to take and make every single one of these positive. So instead of negative 2, I'm going to have 2. Instead of negative 1, I have 1. And then I have 3 zeros. And then 3 more zeros. And then 1 and 2. And now I'm going to find the mean of this last column. Okay. So to do that, to find the mean, we're going to actually just find the sum. Okay. Add those all together. 2 plus 1 plus a bunch of zeros plus 1 plus 2. That's 6. Okay. And then I'm going to take the mean deviation is 6 divided by, there's 10 data values, or 0.6. And there we go. There's the mean deviation for set A. I'd like to do it all again for set B. Okay. So I'm going to set this up again. Oops, sorry. Let me label I'm doing set B. Set B, which also has a mean of 3. Okay. So up here, I'm going to do the data value. Oops, sorry. I clicked off my screen. You didn't get to see that, but I did. I'm going to do my data value. I'm going to do the data value minus the mean. And then the last column, I'm going to make it positive. Oh, wow, that's so annoying. X sub I minus X bar. If you don't like that X sub I, if that like bothers you at all, you can write instead the words. You could put data, and then you could put difference, and then put distance, however you want to kind of write that down. All right, and then let me go ahead and actually put all the data values here for X sub I. For set B, it was 4 ones, 1, 2, 3, 4. Then we had a 2, then we had a 4, and then we had 4 5s. So 1, 2, 3, 4. Okay, there we go. Again, I'm going to kind of draw the halfway mark just so I can use it for my visualization here. Okay, so I'm subtracting 3 from each of these. 1 minus 3, which is just going to be negative 2, negative 2, negative 2, negative 2. 2 minus 3, that's going to be negative 1. 4 minus 3, that's positive 1. 5 minus 3, that's 2, 2, 2, 2. Okay, so I hope you're okay with the fact that I didn't write all of the subtractions. I just wrote the first one on that one. I didn't even write it, of course, on the last one. But if you want to write them all down, you're welcome to. I'm okay with you just, because these subtractions are pretty easy, I'm okay with you just doing it. Or even in the calculator, I'm okay with that too. Okay, now we're going to take the positives of all of these. So basically, everything becomes a positive instead. And I'm going to find the mean of this column. So I'm going to add these all together. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8 2s is 16, plus the 1s is 18. Okay, so for the mean deviation, I'm going to take that 18 and divide it by 10, which is 1.8. So on average, we're saying the data is about 1.8 away from the mean in set B, but for set A, on average, the data value is only 0.6 away from the mean. So there we go. We could see immediately a difference. This has 3 times the distance. 1.8 is literally 3 times 0.6. So we can clearly see that the mean deviation is different for these two sets, which makes sense since we know that one set has way more threes. Everything is way more centered. And yet in the second set, everything ends up being further away from the mean. All of them kind of end up being at the farthest away points, the 1 and the 5. Okay, now there is a severe problem in calculus with the absolute value. Okay, that's why I wanted to mention it, is because that's why mean deviation isn't used in statistics, because we need to have some calculus and it's a problem for calculus. Okay, absolute value is a problem in calculus. You don't need to know why, you could just trust me. So therefore, they introduced a different method of finding this average. Okay, and that's called the standard deviation. And I hope you guys have heard this before. Standard deviation. More complicated. It kind of starts the same, okay? But when we get to the part of making the positives, that's where we have to make a change. So we still find the mean. All right? And we still find the difference between each data value and the mean. I'll write it like that. Okay? We're going to still find all of those differences. But instead of just making them positive, we're going to raise them to the power of 2. We're going to square them. And what that does is it does make everything positive. It also makes everything bigger, okay? But it gets rid of the negatives. And the square isn't a problem in calculus, okay? So we're literally going to square all of these. Here, I'm going to write that down. I'm going to take them and I'm going to multiply them by themselves, okay? Then I'm going to have to undo the square, but I'm not going to do that yet. Before I undo the square, I'm going to find the mean, right? I'm going to find the mean of the squared differences. Which is basically finding the mean of all the things I got in part 3. And then to get rid of the square, I'm going to take the square root of the final answer. Or the square root of the mean. That doesn't look like an A, but it is. Take the square root of the mean from the squared differences. Okay. So here's what it kind of ends up looking like. The standard deviation ends up being that we add up. Oops, I'm sorry. They actually put, I'm going to abbreviate it. Standard deviation ends up equaling, sorry, the square root of adding all of these differences up, x1 minus x bar squared, second data value minus x bar squared, third data value, for, right, all the way down to the last data value, which we've been calling x sub n squared. And then since there's n of them, we divide it by n and we'll take the square root. That's the formula they use to find the square roots. It seems a little more complicated. It actually isn't too bad. And we can still use a table just like we did before. Okay, it really isn't that bad. It just has this extra step of finding the square root, really. Okay, here we go. So let's do the same thing with set A and set B. Okay, we're going to find a standard deviation this time for set A. So again, we're using that the mean is 3. Okay, but this time, Go ahead and make my little table here. Still have all the data values. We're still taking all of the differences. But instead of just making them positive, I'm squaring them. Okay. So all of the data values, 1, 2, 3, 3, 3, 3, 3, 3, 4, 5. Okay. So if we subtract the mean from all of them, it's going to be the exact same thing we just got above for the mean deviation. 1 minus 3 is -2. 2 minus 3 is -1. 3 minus 3 is 0, 0, 0, 0, 0, 0 again. 4 minus 3 is 1. 5 minus 3 is 2. Okay, so I'm not going to write out the subtractions. Now I'm going to square them, multiply them by themselves. So -2 times -2 is 4. -1 times -1 is 1. These still all stay 0. 1 times 1 is 1. 2 times 2 is 4. And there we go. And we're still going to find the mean. Like at this point, we're still going to do the same step that we did above. So I'm going to add them all together. So that's going to be 10. All right. Now here's where it's different. Okay. Here's where it changes. So I'm going to take 10, divide it by 10, and then take the square root. That is going to give me the standard. I don't know why I put this so far over. Wow, let me fix it. The standard deviation. So I'm going to take the square root, taking that 10 divided by 10, and I'm going to take the square root of it. Okay, which is basically the square root of 1, which we happen to know is 1, because 1 times 1 is 1. There we go. That's the standard deviation for set A. Let's look at set B. Set B also has a mean of 3. Also going to organize the data exact same way. X sub I minus X bar. It's all going to be identical to the mean deviation, and then we're going to square it instead. All right, here we go. This one was 4 1s, and then a 2, and a 4, and then 4 5s. All right. Subtract 3 from each of these, which will give me 1 minus 3 is -2, -2, -2, -2. 2 minus 3 is -1. 4 minus 3 is 1. 5 minus 3 is 2. And 2 again, and again, and again. All right. Now I'm going to square each of these. -2 times -2 is 4. -1 times -1 is 1. 1 times 1 is 1. 2 times 2 is 4. All right, there we go. There's the squareds of those differences. Now I'm going to sum them. Lots of 4s here. 1, 2, 3, 4, 5, 6, 7, 8 4s, which is 32. Adding those 2 1s, it's going to be 34. You can get your calculator though, of course. All right, so for the standard deviation, I'm going to take 34 divided by 10 and square root it. So I'm going to take 3.4 divided by 10. I'm sorry. Yeah, 34 divided by 10 is 3.4. Wow, I can talk. And then the square root of 3.4, I'm going to have to do that in the calculator. Okay, so I'm grabbing my calculator. Square root of 34. 3.4. 3.4. I get 1.8. Oh, hey, look, that's very close to the mean standard deviation. I'm sorry, to the mean deviation. That's cool. So this one actually kind of came out the same. That's cool. But the other one ended up being a 1 instead of 1.8. Okay, so it ended up kind of upping it a little bit. But they were not that far off in their values from the mean deviations, okay, which is kind of interesting when you think about it. And that is the way they prefer to find this average because, again, it helps with the calculus.